David Smith here with one more flipped classroom math video lesson. 3 tips before we start. First, remember that you can adjust the playback speed as you desire. Second, you can pause the video at any point to jot down notes or write down questions. Third, you can turn on the captions so you can read my words on the screen. Today's topic is parallel and perpendicular lines. Now I'm going to move really fast after this brief introduction and go right into some IB type problems that you'll get using these concepts. But if you want a more full review of what parallel and perpendicular lines are, just click the link below in the comments, and I have another video that just spends time talking about that in greater detail. But a quick review. So check this out. 2 lines are parallel if they never meet, so they have exactly the same slope. We write it like this: L is parallel to M. So there's your notation. This is what this might look like on a graph. Parallel lines have same gradient. Okay, so if you can find the slope of line L, it's going to be the same as the slope of line M. Okay, second thing, perpendicular lines. They cross at 90-degree angles. That's that little square. That means that that's a 90-degree angle. These lines are perpendicular. We write that this way. Line P is perpendicular to line Q. These little signs are actually kind of convenient. Parallel looks like 2 parallel lines, and perpendicular does look like something showing us a 90-degree angle. Okay, now there's an added complexity with perpendicular lines that we need to look at. First off, check this out. Perpendicular lines have gradients that are the negative reciprocals of each other. Now that sounds like a bunch of gobbledygook coming out in words. In math, it's actually not so bad. Let's take a look at what that might look like. Let's say that the slope for Q, it's a negative line, and we're going to say it's -3/2. So that's my slope for Q. What that means is that the slope for P is going to be the negative reciprocal of -3/2. So reciprocal for a fraction means you just flip the top and the bottom. So M would be 2/3. And since this one is negative, that one's positive. So if I tell you the slope of one line, then you know the slope of a perpendicular line. You just have to flip the fraction and change the sign. Now there's one more complexity to that. That complexity is that the product of the gradients is -1. So what we're going to do is we're going to use this idea to test these 2 gradients. Does that really work? Is their product -1? So watch this. Here we go. We've got -3/2 times +2/3. When you multiply fractions, you go straight across. So I'm going to put the negative with the 3. It doesn't matter as long as you keep it in there. So -3 times -2 is -6, and 2 times 3 is +6, and this does equal -1. So those slopes are indeed perpendicular. These 2 lines are indeed perpendicular. So you're going to have to leverage that information to solve and work some of the problems. So obviously, you're going to need to be able to calculate or find slope in all the ways that we've found slope so far in this chapter. Let's warm up with a straightforward IB type word problem dealing with parallel and perpendicular lines. So here's what we're doing. Line L has equation y equals 2x plus 7. Cool. Line M goes through these 2 points. The question is, are these 2 lines parallel, perpendicular, or neither? Right? So I'm just going to do parallel, perpendicular, or neither. Now, like I said, it comes down to slope. So if you have a feel for how to do this problem, pause the video right now and see if you can figure out whether they're parallel, perpendicular, or neither. And let me say, don't graph it. Okay? All right, let's see how you did. So line L has this equation. So we know the slope. This is slope-intercept form, or gradient-intercept form. So for L, the slope is 2. We get it right out of the equation. So we're halfway there. This line, it goes through 2 points. The slope is not apparent. So for line M, we need to do, I'm using M for slope and for lines. Okay. We need to do the slope calculation. So y2 minus y1 over x2 minus x1. So let's call this point 2 and this point 1. So we're going to get 8 minus 9 over 3 minus 1. It's going to be negative 1. Oops, I wrote 2, but I meant negative 1. Negative 1 over 2. So that's negative 1/2. Now, okay, the slopes aren't the same, so we know it's not parallel, but we don't know about perpendicular or neither. So now we need to analyze these slopes. I can see now that they are perpendicular because 2 is the negative reciprocal of negative 1/2. Think about it this way. 2 is written as 1 over 2. So to find the negative reciprocal, we flip the fraction and change the sign. So that would be 1 over 2 negative. As a final check, we can multiply these two and make sure we get negative 1. So 2 over 1 times negative 1 over 2. Multiply straight across the top, we've got minus 2. Multiply straight across the bottom, we got regular 2. And that is negative 1. Let's try another calculation. This one a little bit more complicated, although I'll tell you, the complexity for this problem is not in the actual math that you have to do. It's pulling it out of the word problem. So let's go over that word problem first. I've got a plane that flies on a straight line we're calling L1 with the equation y equals 2x minus 5. So this plane is going along in a straight line like above a coordinate grid, so we could actually map the plane's path as y equals 2x minus 5. Okay? Now there's a second plane. Flies at the same altitude. So right there, you might be thinking, hey, we better not let these planes crash into each other. They're at the same altitude, so it's possible they could. So the second plane flies at the same altitude along path L2. Okay, different line. What we need to do now is find an equation for L2 so that it doesn't intersect L1, good thing, no plane crash, and passes through the point 3, negative 1. Okay, so basically you need a second equation that doesn't intersect this one ever, and it goes to the point 3, negative 1. So pause the video and do a little bit of thinking about that. See if you can kind of contextualize that problem down, boil it down to just the math. Now if you feel like taking it all the way through the end, just go ahead and do that. Okay, in terms of math, we need the equation for a line that's parallel to this one. L2 has to be parallel to L1. That way they'll never intersect, and it needs to go through this point. So that's kind of the boil down of the math. Now parallel lines, what do we know about their gradients? They're the same. So L2 is going to look like this. It's going to be y equals 2x plus b. We don't know what b is, but we do know the slope. Okay, so we're kind of halfway there. Now, pause the video if you haven't already done this, the rest of this, and figure this out. You have the information you need right there and this to fully find the equation for L2. Okay, if you realize that I can use this point in this equation to find b, you're on the right track. So all we do is we just plug in the y and the x coordinate. We go y, that's minus 1, equals 2 times 3 plus b. So negative 1 equals 6 plus b, subtract 6, minus 7 equals b. So now we found our b, so our equation is y equals 2x minus 7. Now that equation will never intersect this one, the planes will never crash, and then the added information is that it does go through that point. Let's do a more complex IB-style word problem. This one is squarely within the realm of coordinate geometry, which in fact we've been in for a while now. Coordinate geometry is just geometry on the coordinate plane, so you can plot points, calculate slopes, things like that. So this problem involves Bob, our math dude, and he's planning a parallelogram-shaped garden. It's just what he wants, don't ask me about it, with vertices P, Q, M, and N. You can see I've given you coordinate points. So obviously he's planning this out probably on graph paper or something like that. So the first question is, show that this is a parallelogram. So think about parallelograms for a minute, and then think about the points, and see if you can come up with a strategy for solving this. Okay, one essential piece for this is to draw a diagram. So I'm going to do that over here. Generally speaking, a parallelogram looks like a squished rectangle, okay? And then opposite sides are parallel. So that's what these arrows mean. The two arrows indicate that these two sides are parallel, and these indicate that those two sides are parallel. Now I'm going to label my points P, Q, M, and N. Now I'm going to go further. I'm going to put the coordinates on them. So this one is 7, 3. This one is 13, 2. This one is 8, negative 2. And this one is 2, negative 1. All right. So now we need a strategy. What are we going to do? I think I gave you enough clues there. But if you're not sure yet, pause the video and think about that. What do I need to do to show that this thing is a parallelogram? Okay, if you came up with, well, we need to find out if the opposite sides are parallel. Okay, great, good. And how we do that is to find their slopes. And we have the coordinate points for every corner, so we can do that. So the first thing, I'm going to try to find out if PQ is parallel to MN. So I need the slopes of both of those. So PQ, the slope of that is going to be y2 minus y1 over x2 minus x1. I'm going to use 13, 2 as my second point. So it's going to be 2 minus 3 over 13 minus 7. 2 minus 3 is negative 1. 13 minus 7, what do I get? I got 6. So that slope is negative 1/6. Now let's try MN. I'm going to use the far one as my 2. So that's minus 2 minus negative 1 over 8 minus 2. So negative 2 minus negative 1 is negative 2 plus 1. So that's 1 over 6. And I do have a negative in here, right? Yeah, that's negative 1. Okay, so this tells us that PQ is perpendicular, parallel to MN. Are we finished? No. We need to prove that the other pair of opposite sides, namely PN and QM, that they also have the same slope and indeed are parallel. So let's do that. I'm going to do PN first. So Y2 for PN, I'm going to use 3 minus negative 1. And then for the x-coordinate, I'm going to use 7 minus 2. So 3 minus negative 1 is 4. 7 minus 2 is 5. So the slope gradient for PN is 4/5. And then let's do QM. So QM, we're going to do 2 minus negative 2 over 13 minus 8. And I think we're in good shape. 2 minus negative 2 is 2 plus 2, so that's 4. 13 minus 8 is indeed 5. So PN is parallel to QM. So it's a parallelogram. So we proved that. Part B. Now you're being asked to show that PQMN's diagonals are perpendicular. So first thing I'm going to do is add that to my diagram. So I'm going to draw the diagonals. And I'm being asked to prove that they meet at a 90-degree angle. And let's see what we get, okay? So now make a strategy for this one, thinking about what you know about perpendicular lines and how to show that two lines are perpendicular. Okay, now I'm hopeful that your strategy is as follows, that you're going to find the slope of PM and then the slope of NQ and then check to see if those slopes are the negative reciprocals of each other, because if they are, then those two diagonals are indeed perpendicular. So let's go ahead and do that. Actually, if you want to pause the video and do that first, do that and then check. Okay, let's go. The slope of PM. I'm going to use P as my 2, so 3 minus 8 over 7 minus, it's 3 minus negative 2. Sorry about that. 3 minus negative 2 over 7 minus 8. So 3 minus negative 2 is 3 plus 2 are 5, and 7 minus 8 is negative 1. So this gives us a slope of negative 5. Cool. So now I'm going to make a prediction. If these two lines are perpendicular, what is the slope of NQ going to be? it has to be the negative reciprocal of -5, which would be +1/5. So let's see what we get. That would be n cubed. Boom. So I'm going to use n as my 2. So -1 minus 2 over, that would be 2 minus 13. Let's see what we get here. -1 minus 2 is -3. And 2 minus 13, what's that going to be? That's -11. Okay, so I finished that up, and here's what I get. The slope of n cubed is 13 over 11. And that's not the negative reciprocal of -5, so the diagonals are not perpendicular to each other. Now that you've watched the video, take a moment to jot down additional notes, some questions for class, or a short summary of the lesson. You can also go back and re-watch the portions of the video that were a little bit challenging for you. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.